from the internet or from other databases also. When we look at collection of data from databases and internet, we call it e-tools, in the sense electronic tools to collect data. Lot of data collection is done on the field and uploaded on the internet for people to use. As well as we can also do some data mining to collect some primary data from the internet, where if we consider internet as the primary source of data. Let's look at how do we collect primary data from the e-tools that are there. One of the important things that we do while collecting primary data is we use a questionnaire. And we have a very nice ecosystem developed for administering questionnaires of surveys. There are so many survey tools that are there nowadays on the internet. One of the oldest one, of course, happens to be the Google Forms, which people have been using left, right, and center to collect data. Apart from that, there are so many other tools like you have Go Survey, and then you have something called as Go Survey, and then you have something called as a Survey Monkey, and then there's one more tool called as Typeform, and of course Google Forms. There's something called as Client Heartbeat, and Zoho Survey, and Survey Gizmo, and Survey Planet. All these tools basically help you in framing a questionnaire. And when you frame a questionnaire, you can frame a questionnaire for multiple choice questions, or drop-down menus. You can do picture for this thing also, picture forms also, questions also, where you can ask on pictures. You can do match the following. You can also limit the number of words that are required. You can also do something like in these electronic tools, in these electronic forms you can, I'm sorry, I got disturbed somewhere and distracted somewhere by somebody. Yeah. You know, in these electronic forms, you can do match the following. You can do drop-down menus. You can say that unless you answer this question, you can't go ahead. Whereas in physical questionnaires, you cannot say that you have to compulsorily write something or you have to compulsorily answer some question or something like that. Here, that is there. You can easily say that these questions are compulsory, you have to answer them. And there are a lot of advantages. Another advantage is if you are doing a ranking, let's say, unless you give a rank, you can't go ahead. And the rank will be between 1 to 10 or 1 to 5 as you define. So if you in physical questionnaires, what would happen is you put in a box and you ask them to write something in the box. Sometimes people write anything. If you ask to write between 1 and 10, they would write 11 also. But you don't have control over. But here that is not there. You can have control over what goes into the form, and you have control over with every question whether it is compulsory or not. You can make it compulsory. You can leave it. You can leave it at not compulsory or compulsory kind of thing. So that is there. One disadvantage is that people whom you are administering this questionnaire, they have to have access to computers, access to these equipment. Of course, when you are doing field studies, you can give this to your field investigator, and the field investigator can carry a tab or something to the field ask people and then tap those answers on the tab. So that is of course possible. But then the cost of giving a tab to the field investigator also has to be taken into account. So in one way it is very cost effective because all you need to do is send an email, prepare a questionnaire, send an email and wait for the answers. In another way it is expensive because you prepare the questionnaire, send an email, then keep on following up, make phone calls, send messages or send a field investigator and physically follow up. So if you do a lot of physical follow-up means expensive, no physical follow-up means very easy also. Apart from being used as a survey tool, it is also being used nowadays to prospect for new clients, for new customers. So it has become a marketing tool also. Of course, the first line there says questionnaire embedded in your website. You can always, many times if you go to visit a educational institution website, you will find there is a questionnaire embedded in the website because they are looking for admission inquiries, and admission inquiries can be easily collected from the questionnaire on the website. Similarly, feedback can also be collected. Survey also can be conducted using a questionnaire which you embed on your website if you are not so much interested in using these tools. I would also like to bring your attention to another very interesting thing that happens on the internet these days. I have put down some addresses there, some URLs there: www.keyword.io, www.trends.google.com, mondovo.com, socialmediatoday.com, wordtracker.com. These are very interesting websites. If you visit these websites, you can search for the most trending search keywords, the most trending keywords. So you will know that today which was the word which was being searched most of the time. So that is there. Apart from that, if you are interested, let's say in doing a survey on e-banking, you can go to one of these sites and you can just search. You can just put, let's say, e-banking in the window, in the search window there, and search for e-banking. It will tell you how many times e-banking has been searched for as a keyword. So it also gives you an insight into what is the most popular keyword. All these sites give you that insight into which is the most important keyword. And once you know which is the most important keyword, you can use that in your survey tool so that the survey tool becomes popular. When people are searching, when you are doing some random survey, when you are doing a survey for let's say a global survey, then you are not continuously searching for respondents. What you can do is put those keywords in such a way so that whenever people search for those keywords, your form pops up and there you will be able to collect data. So that's one gimmick that lot of these online surveyors, online marketers have been using and which goes very well as a primary data collection tool. I see a lot of people still in the waiting room. Could somebody please get them in because they're...
Yes, so we're trying to get them in as soon as possible.
The problem is they are crowding up my screen, so I have not been able to see this.
Bhumi, change the...
Anyway, that's all. Just admit all of it.
It doesn't disturb, sir.
Ma'am, sir is sharing the screen. So,
Fair enough. I think they're all coming, so not a problem. Anita Paple has entered the
It
meeting.
takes a while till they join after we
Yeah,
give them
yeah,
permission to join.
Yeah,
And hence
okay.
they are coming up on the screen.
Fair enough. Fair. Okay, let's go to the secondary data collection. That's where search engine trends also come in. It will tell you which keyword is trending and what are the trends in the search engine. That's one. Second one is the search engine themselves are secondary data collection tools. You can collect a lot of data using Google or Bing or DuckDuckGo or something like that. Then there are specialized websites. And these specialized websites are a treasure trove of secondary data. For example, if you're looking at stock market data, then nseindia.com and bseindia.com, they have excellent archives which can give you data right from 2000 onwards. Then there is, of course, the most academics these days are flaunting this tradingeconomics.com. This is another website where a lot of data, a lot of interesting data is available. I'd like to, I think I should click on one of them and try to show what is possible. Let me check whether it's. Yeah, stop screen sharing for some time. Just to go to tradingeconomics.com.
okay.
So that I'll be able to show what is possible. Something interesting which people would be.
Sure, sir.
Yeah. Yes, you can. Can you see this tradingeconomics.com?
Yes, sir.
Yeah. Interestingly, this you can, if you look at indicators and then go to India, there you are. It says May 20th, Indian currency rupee, the dollar is trading at 75 rupees 66 paise. Sensex was at 30,822. Government bond, 10-year bond is, the yield is 6.04%. GDP growth rate 1.1%. GDP annual growth rate with reference to December 2019 is 4.7%. Unemployment rate 7.8%. Inflation rate, interest rate, CRR, balance of trade, current account, everything, or whatever you look for in economics is there. It says coronavirus cases, coronavirus deaths, coronavirus recovered, hospital beds per 1,000 people. This is fantastic information available for every country. So if you're doing some kind of research based on secondary data, tradingeconomics.com is a very good place to look for economics data. Also for economics classes for that matter. And it will help a lot of people who are looking for secondary data. So I wanted to show this. One more thing that I wanted to show was our friends who are doing PhD. We are a little bit, I think we are. Yeah, I'm lucky. Anyway, there is this website called ssrn.com, which I have already mentioned in the PPT. This has curated something like it is as good as a Scopus or Elsevier kind of thing, which is an open source database for research articles. So very good for literature review. That will help hugely for literature review. Okay, so that is what is secondary data. By the way, let's go back to the let's go back to the presentation. Yeah. So trading economics is there. Then kitco.com is there. Kitco.com gives you information about all commodity markets, especially gold and silver. Fantastic place to look for commodity markets and international markets. Then if you are interested in international stock markets and international economics, another website is marketwatch.com. Marketwatch.com is by Wall Street Journal. They are again leaders in vending information, financial information. Then of course we have our own census.gov.in. Census, of course, 2020 new census has to happen, but 2011 census data is available. Gives us excellent information, excellent data on lot of socio-economic factors. Then rbi.org.in, which gives again a lot of economic information. So all in all, there are a lot of specialized websites like this. These are only a few which I have listed, but so many more are there which can give you information about economics, about socio-economics, about a lot of other areas also, and which helps in building a case for our primary research, building a case for our literature survey. So these are secondary data sources. Now let's look at descriptive analysis of data. Whatever data we collect for research, we end up describing that data, and many times our analysis ends at only describing the data. It's very, nowadays people are going beyond the description of data, but nevertheless, a lot of people still stop at describing the data. They just describe it and then leave it at that. But nowadays, again, people have moved a little bit higher. One of my PhD students, who's going to, of course, present, I think, the second last session, Chetan GK, he has worked, he is from MDI Murshidabad. He has worked on Arch, Garch, and also, that is one step ahead of description. You do real analysis, try to find out causal effects, etc. But otherwise, people end up doing only descriptive analysis. So if you are doing descriptive analysis, and you have nominal data, so what kind of descriptive analysis does one do with nominal data? One of the popular analysis is developing a frequency table, describing the proportions, percentages, and mode. If your type of measurement is ordinal, if you have collected ordinal data, then what do you do? Then you describe it by calculating the median, presenting the quartiles, the percentiles, or go one step further and do rank order correlation. And if you have collected interval data, Usually when you collect interval data, what you do is you describe it by using the arithmetic mean and go one step ahead and do correlation coefficient. And if you have collected ratio data in the form of variable in the form of ratio, then what you do is use describe it by calculating index numbers, by calculating geometric mean, harmonic mean, etc. So that's how you use these different different scales and how you do analysis of those different scales. Morning we were talking about validity, and one of the descriptive the analysis of univariate data is missing data. You have a small example here where you collected data from 414 people. Out of the 414 people, 285 people are single, 128 people are married. That comes to a total of 413. So one person has not said whether he or she is married or single. So that is the missing data. Total comes to 414. And you find as a percentage, 68.8% people have declared themselves single, married, 30.9% people have declared themselves married. Total comes to 99.8, that is 0.2% missing. But when you look at valid percent here, when you look at SPSS gives you this kind of an output. So valid percent, 69, 31, that's 100%. Out of the valid entries means 413 entries are valid. Out of them, 69% are single, 31% are married, and so it is 100%. And the missing one is left away. So this gives us this kind of descriptive analysis gives us a mental picture of the distribution of whatever we have collected. I'm sorry. Now, when you have a large data set, here the example numbers are very small, but I did not put in big numbers. You could put large numbers there. When you have large data sets, what you do is you group them. So what basically is being done here is those people who said first rank or who gave rank 1 are 16 and they are 50%. Those who gave rank 2 are 13. So basically you are describing all the 32 people how they have ranked up for an attribute in the question. So this can be 320 or 3200, and proportionately the frequencies would also change. So this is basically converting a ordinal an ordinal data into interval data. Excuse me. Yeah. Then another way of describing data is the mean, median, and mode. Since most of us have studied this long back, I thought let me not spend too much time on this. But nevertheless, I thought let's just look at these measures of central tendency and talk about where they are useful. When you are using mean, the arithmetic average, it's good for ratio and interval data. It can describe any ratio data and interval data nicely. Median, a point where 50% is above and 50% is below the median, It's also good for ratio, for interval and original data. And mode is something which is good for the nominal scale. So since there are 856 participants here, and since the 866 participants here, chat window is open. Probably, we can do a small survey, but it would take long time to collate the data. Otherwise, I could simply say, please type your name, please type the city from which you are watching this webinar, and then lo and behold, I'll get 866 responses. Once I get all these responses, this is all nominal data. And looking at those responses, I can say, I'm just hypothesizing, I can say that maybe 30-40% of them are from Mumbai. How do I come to know? That's the mode. The highest number of people from a single city become the mode of this data. So such thing can be used. And this is a very very powerful tool that way. Arithmetic average, median and mode, mean, median, mode are very powerful with respect to description of data. COVID-19 mortality rate has been estimated at around 3% worldwide. How do we come to this conclusion of around 3% worldwide? It is nothing but an arithmetic average of all the mortality rates across the nations who are affected by this virus. So that's a central thing. Maybe some country has it at 7%, some country has it at 2%. Only describing a central tendency does not describe the entire distribution. Sometimes lack of symmetry has also needs to be described. That meaning that if mean, median and mode are all same or all equal, then what does it mean? It means that all the data is distributed evenly between on both sides of the mean. But if mean is more than the mode, if mean is more than the median and median is more than the mode, then what happens? There is a tail on the right side. There is skewness in the distribution. Similarly, there is a negative skewness when mean is less than the median and median is less than the mode. There is a longer tail on the left. Skewness is a very important description of data when it comes to measuring performance of various students. When we start measuring performance of students, we will find one or two of them scoring 10% and a majority of them scoring somewhere 50 to 60%. Sometimes in some colleges you will find that a majority of them score between 70 to 80%. And in some colleges majority of them score between 30 to 40%. This is skewness. This is what is lack of symmetry. If the mean score of all the students was 50% and median was also 50%, median of course is 50%, mode was also 50%, that would mean that this is a normal curve and it's a symmetrical curve. But there is possibility that there is positive skewness, that is mean being higher than the median and than the mode. So if the mean was, let's say, something like 70% and the median of course is 50 and mode would be a little bit lower, then there is no symmetry. So if you want to describe symmetry, then you need to know skewness. Another measure of dispersion is range. Measure of dispersion. Range basically tells us what is the lowest, what is the highest. So difference between the maximum and minimum value of variable. How if there is a, let's say, a race, the minimum time taken in a 100 meters dash maybe 9.8 seconds or something, maximum time 10.4 seconds. So that is the range, that may be the Olympic range, and the international World Cup range may be something like 9.9 seconds to 10.5 seconds. The national range may be 10.2 seconds to 10.8 seconds. So this is a measure of dispersion. This tells you where that specific variable is. So range is also used to describe variables, how they variables and a data set on how they behave. Then variance. Variance is mean squared deviation of a variable. Basically, why squared? Because from the mean, the deviation can be negative or positive, and if there is negative deviation, it's better to square it so that you make it positive. Variance gives us, again, it gives us a very good idea of how much is the dispersion. Standard deviation, of course, which is one of the favorites to calculate dispersion, to present dispersion, which is a positive square root of the variance. Variance is a little bit difficult to explain. So standard deviation is easy to explain because it's nothing but the average of the deviations. It's easier to explain that way. Then, of course, coefficient of variation, which measures relative dispersion of two or more distributions. It tells us how two or more distributions have changed. Now, lot of PhD thesis these days work on this crosstabulation, and a lot of people do this crosstabulation. So I've just put in a very small example of crosstabulation here. It's a cross table of purchase intention and income. There are basically 250 responses from the high income group and 200 responses from the low income group. And those with low income and low purchase intention are 120 responses. Those with low income and high purchase intention are 80 responses. Those with high income and low purchase intentions are 60 responses. And those with high income and high purchase intention are 190 responses. When you look at this, if somebody is doing a marketing survey, this 190 becomes the target market. And this segment of the market is best ignored because there's neither affordability nor intention. Whereas this 190 becomes the target market. I hope whatever I'm drawing is visible on the.
Yes, sir.
Yeah. Okay. And then high income and low purchase intention is something which you coax them to buy. This is where advertisement or your sales promotion works on. You need to put in efforts on this to convert them, these high income people, into high purchase intention people. Whereas this is a very dicey thing. This is another dicey thing, because there is low income and high purchase intention. If there is high purchase intention and low income, and if you are dealing with, let's say, motorbikes or something, then this is the category which you refer to the finance company and give them some loans to buy your stuff, buy your products. So such a cross table helps us in understanding whatever data we have collected, and also helps us to take decisions. So descriptive analysis, when you use for bivariate data, probably helps us in taking decisions also. Of course, univariate data also, it helps us in taking decisions, but this gives us some interesting, this kind of a cross table throws up some interesting results. Okay, let's. Then there is this Spearman's rank correlation coefficient. In case of ordinal scale data, you would like to know if there is an ordinal scale. If you are asking people to rank an attribute, then you would like to know what is the consistency of these ranks, especially when you're using let's say field investigators and sending them off to various places to collect data or to rank certain things. Every field investigator would have gone to different localities, and the localities can be of different social strata also. Suppose when they come back, you want to know how consistent they are in awarding these ranks. That's where Spearman's rank correlation coefficient comes into play. A simple example there, which I've written, is suppose in a beauty contest or maybe a dance reality show or something, 2 judges are asked to rank 10 female participants. The rank correlation coefficient between the ranks awarded by 2 judges will tell us whether both these judges are consistent or not. If they are consistent, then probably the rank that they have given in the beauty contest holds good. Sometimes if they are not consistent, then probably there is a chance for foul play. So this kind of techniques help us in understanding the ordinal scale data and understanding consistency of the ordinal scale, and which will help us in doing the analysis. Okay, so I think started at 4. Let's wrap it up. I require some more time on this wrap up, because we are doing some very interesting things on this. First, let's look at e-tools. Due to the COVID-19 situation, due to lockdown, nowadays we have started using e-tools to a large extent. And if you look at your WhatsApp, since everybody is from academic community, if you look at the WhatsApp, you'll find that at least once a week you get some kind of a link for a survey form. And people keep on exhorting you, people keep on asking you to answer that survey so that they can complete their data collection. So data collection one of the biggest helps that has come is from the e-tools. People have been using all these e-tools to collect the required data. Companies have been using these e-tools to collect customer feedback, collect prospective feedback, to find out new customers. They are also using e-tools for employee feedback, for managing employee resources, and a whole lot of things. When we start looking at these Google Forms and SurveyMonkey and all, one interesting thing that comes up again is that every time you use this data, use this e-tool, you tend to give all this data to the company which runs this e-tool. So you are not only doing your survey, but you are also helping that company to collect socioeconomic data of not only you yourself, but also your people, your respondents. So question is how good or bad it is, whether GDPR is being followed, not followed, and that is one ethical question that pops up. Not only for your PhD, but for somebody else's data collection process. We are collecting data. And if you are collecting date of births, I think then there is a big issue there, because all public databases are bound to be hacked. Unless they are point-to-point encrypted messages, any public database for that matter is not safe at all. All said and done, they are sitting on a server, and that server can always be hacked anytime. So e-tools pose a big threat in the sense that data can be compromised, and that we have to take care and evolve some way of stopping people from using the data. Many times, if you are into, when you use banking channels, when you request for statements, when you get mutual fund statements, when you get bank statements, when you get seemingly simple statements from anywhere, those statements tend to have some encryption, like the PDF file tends to have some kind of a password. And sometimes you feel this is not so important. Why should this kind of a document have a password? But if you start really thinking deeply on the amount of data that is being collected on those servers, then I think what people are talking about, encryption or security is very important. So I would rather suggest, when you conduct surveys, there are possibilities where you can encrypt the data. It's better to encrypt the data. Secondly, important data sources. One of the biggest pitfalls of these internet-based data sources, which people have been using, is this Wikipedia. Everybody knows that Wikipedia is editable. Anybody with a email ID and with a login ID and a password can edit whatever is written on Wikipedia. But still, lot of people end up using Wikipedia as a data source. I think we should now get into a mission mode, get into some kind of some kind of an arrangement where academics start stopping the use of Wikipedia as a source of information. And data sources other than those um, which are promoted by media houses, promoted by self-regulatory organizations or the government. The only media houses, self-regulatory organizations and the government, only that data should be used as a data source. For example, let's say Bank for International Settlements, BIS.org, or WHO data, or UNESCO data, or World Bank data, IMF data. These are all important data sources. These are authentic. But many times, or tradingeconomics.com, which is again a SRO, these are all good data sources. But people tend to use data sources which belong to any website which neither has a media license nor has any other authenticity. But people throw up that data, and then something like crowd-funded data source, or in fact, there is one data source which is very rapidly gaining maybe acceptance, but I don't know whether the data is correct or not. There is one data source called COVIDindian.org, and people say that this is a data source. This is a website which is which works on the principles of crowdfunding. People come over and submit data to it, and that data is used to tell us what is the score of COVID in India today. COVIDindia.org data and the Ministry of Health and Family Welfare data are two different data points. There is a small difference between both of them. So which one to be considered as authentic is a question. So when you look at important data sources, I would suggest, that's my humble submission, that we should look for authenticated data. We should look for data for which somebody takes responsibility, like the government or a self-regulatory organization, or maybe an international organization, or a media house. Because media house, because they are journalistic, they have journalistic license, and as a media house, they are entitled to publish it. So that's one thing that one has to take care. And coming to descriptive analysis, a regular joke that goes around is a camel is a horse as described by a committee. That's how descriptive analysis is joked about. There was somebody who said lies, damned lies, and statistics. Again, what he was talking of was statistics can be manipulated in a way to look good or to look bad. For example, again, let's take a very simple example. India's GDP growth. India's GDP growth from 1 trillion economy to 2.6 trillion economy for the last from 2003 onwards to 2020. So that's 17 years. The average growth would work out to around 7% or something, or sometimes more also. Now, expecting a 1 trillion economy to grow by 7%, is one thing, and expecting a 3 trillion economy to grow by 7% is another thing. Expecting a 30 trillion economy to grow by 1% is something else. So as the size of the economy grows, this growth of the economy, percentage growth of the economy sometimes loses its sanctity. When we look at descriptive, when we start describing our data, we need to make sure that we are comparing apples with apples and not apples with oranges. Somebody who has collected, for another example is, I was I was doing some consultation, some statistical consultation to a clinical research that was going on. And the number of rats that were used for that clinical research was 6. Only 6 rats that were used. And enough data was being collected, but the number of rats was very low. The number of subjects were very, very low. And he wanted to use some statistical analysis to prove certain points. The question is, when your sample size is very small, can you do justice to this kind of research? Can you do statistical justice to this kind of research? So descriptive analysis, you could easily mold it the way you want, because there are only 6 rats around. So it becomes all the more important when you are doing descriptive analysis that the size of the data should also be good enough, should be big enough. During MBA, during MBA teaching days, I used to insist that students collect data from at least 300 respondents. Well, I used to feel comfortable about 300 respondents. But some people tend to do a project with 50 respondents. It really may not bring out the correct picture. So that is one pitfall in descriptive analysis. One has to look at the sample size, and the sample size has to be big enough so that manipulation of results does not happen. Then we also refreshed some basic descriptive statistics like measures of central tendency, skewness, dispersion, and ordinal scales, etc. The idea here was not to go to the statistical details, etc., but to give a fair idea that this is what it can be used for. These scales, nominal, ordinal, interval, and ratio scales, they have these tools which can be used. So that was the only idea. The idea was not to teach any statistics. I'm no statistician by any nature. But that's what it was all about. So thank you very much for the patient hearing. I'm open for questions.
Thank you so much, sir. Now.
Yeah.
Dr. Chandrasekhar, please go ahead with your question.
Yeah. Good afternoon, sir.
Good afternoon.
Yeah, sir, I would like to know when we ask questions in a Likert scale, for example, if the responses range from strongly disagree to strongly agree.
Okay.
In that case, is that an interval scale or is it an ordinal scale? Because if we consider it as an interval scale, then only we can apply a test of means and all. But
yes.
And we come across so many researches where we easily apply that. But if you, so I'm a little bit